Speaker is Steve Crusan, and he's going to talk about balance systems and a new benchmark called the IO 500.
All right, can everyone hear me? All right, so the IO 500 is a new benchmark we've been working on over the past 5 years. It originally came out of Seagate Government Solutions, Los Alamos National Lab, and a lab in Europe. The reason is, especially for people that work on RFPs, either from vendor side or the storage side, and all the way down to the users. A firmware engineer is going to tell you a disk can do 180 megabytes per second. Marketing is obviously going to be double or triple that. Performance engineer, maybe someone like me that does technical sales and tuning, probably a little more realistic. Salesperson, 100 megabytes per second, but from a user perspective, you're usually going to see 10 megabytes per second your application, which you're as a user, you're usually the most important person on that system just because you're funding it in some way. So the motivation here is to determine, okay, can we provide a large bounding box of different workloads that test systems in easy ways and difficult ways with metadata, with data, things like that, in order to give everyone a more realistic view of what you can expect out of a storage system. And the storage system would be your file system, your media, your arrays, things like that, even down to the disk drives. So a concern about Linpack, if you look right here, that might be what you would consider the most balanced system. It might not be the best system for your users' workloads, but in terms of storage bandwidth and memory capacity, as well as your network bandwidth, your L3 caching, things like that, this might be what you consider a balanced system. It's kind of a basic picture, but just to get an idea of what you might think of as a balanced system. A Linpack machine is going to be up all the way at the top because that's going to be testing CPU, network bandwidth, and things like that. There's no storage component to the Linpack systems. And anyone that operates a large machine knows that storage is relatively important depending on what you're working on. So actual computers, can you see that well? Good, okay. Actual machines a lot of times are built to those specifications. So the idea of the IO 500 is to more or less come out with a sort of balance that thinks about IO again and kind of can help you determine how to build the system out, especially if your workload is not purely CPU or memory based. So that would be an IO 500 supercomputer. Again, this is all IO and storage bandwidth. Again, if you were the type of person that was building something like this out, you might not decide to build purely an IO machine unless you're an HPC storage nerd. Nothing wrong with that. So it's important that we want to pick things in the middle. Move everything a little bit closer, because especially if you determine by virtue of your workload, you're spending 80% of your time with CPU and the other 20% of your time is actually doing network and storage, determine how to build out the best systems. And part of the other reason we decided to go down this route is also a lot of people in this room probably have a lot of things to do and don't have enough time, expertise, or a collection of all of your coworkers' times in order to determine what the best system is and how to architect it out. So the idea here is we give you a large reference point for many different systems, many different storage systems, with all the testing parameters that you can use to either tune your systems or just get a better representation of, well, if I know what my workload is, we know this file system just does not do well with this. So the IO 500 is balanced. There's 5 main criteria. At the end of the day, you come out with one number, but we like to advertise all 5 of these tiers. Hero bandwidth, so this is what storage vendors always talk about. I work for a storage vendor, so I talk about this too. This is going to be the best possible numbers you can get, writes and reads, with streaming sequential. You're allowed to cheat, meaning pick out whatever tuning parameters you would like, pick out the most optimal scenarios. If that means that you balance your clients in such a way and tell your clients to write to certain luster targets that are the least number of network hops away, do whatever you want to do. The whole point is to show how you can absolutely get the most out of your system. Just tell people how you did it. The anti-hero bandwidth, that's going to be probably the worst possible I/O workload you can do on a large shared system, especially a POSIX network file system. That's going to be shared file. That's going to be 47,008 bytes. And that's all going to be, every single one of your threads will be writing to that same file. And I'll talk about why that's really terrible, but in a second. But again, and when you look at some of the results, you can see the effects of that. Hero metadata, create, stat, delete, pick whatever parameters you want, cheat as much as you want, that's fine. Anti-hero metadata, that's going to be 49,001 byte writes to the same exact directory from all of your threads at the same time. You just, you more or less just say how many files you want to create and how much you want to destroy your metadata server, depending on which file system you're using. And the last one, the namespace search. And again, when we have the anti-hero numbers, the bandwidth and the metadata, you cannot change those parameters. For the hero ones, you can change it however you want. With the namespace search, this one is the most interesting because depending on what file system you're using, you might be able to use a better version of a namespace search, and that's going to be just looking for a certain number of files across the file system in some way which meet a certain set of criteria. So with GPFS, you can use a GPFS policy engine. With Lustre, you can, I guess you could use Robinhood, but I don't know if you already have everything in there. There's other things coming out for Lustre which might help with this. Again, if you have a file system that has a specialized namespace search that you can leverage for this tool, you're allowed to use it to showcase why your file system is good for namespaces. So the goal here is we want to create a bounding box of all the different parameters, and hopefully one's workload can fit into this bounding box. Let's see if I get to use this thing. So worst possible bandwidth would be the anti-hero numbers, just because I'll talk about why in a second. Best possible bandwidth will be here. Not everyone's application is going to be doing just streaming bandwidth. You might be doing something with HDF5, so you have somewhere in the middle, because it is shared file, there's a lot of metadata updates within the file. But the idea is within this bounding box, everyone's workload can be somewhat explained. It's not going to be perfect, so any